Alright guys, so this video is going to be quickly about a general launch problem, okay? A general launch problem is any kind of problem where you have the launching of a projectile that is not perfectly horizontal or perfectly vertical. Okay, so we're going to see some sort of arcing motion and we don't have an initial y velocity of 0. So, in this case we've got Michael drop kicking a cheetah, a baby cheetah, at an angle of 30 degrees above the horizontal at 30 meters per second, and he is 18 meters above the ground, or the cliff he's on is 18 meters above the ground below. The question we want to know is, what is the final velocity of the cheetah? Okay? So, like any 2D kinematics problem, we got to set it up into x and y. Okay? So, our change in x, we don't know. Our initial velocity of x, though, we do know. And that's going to be 30 times cosine of 30, right? Because we want the horizontal component for angle. The final of x we also know, but we'll get that in 1 second. Acceleration of x is going to be 0. And because the acceleration is 0, that means there's no change in the velocity, which means our final velocity is equal to our initial velocity. Okay, so we'll find that out in a second, and we don't know time. In the y, we have change in y we know. It is negative 18 meters. Very important that we get the negative on there, otherwise we're going to be shooting up onto something instead of down. Okay, the initial, we're going to find the same way we found with this one, except we're going to use sine, because we want the vertical component. So 30 sine 30. The final, we do not know because our acceleration is not 0. Our acceleration is negative 9.8. Okay, and time we don't know either. Okay? Well, what we need to find v final overall, we need to find v final x and v final y. So, since we already know v final x, well, we'll know it in a second. Turns out 30 cosine 30 is 26. Okay? So, 26 meters per second. All we have to do now is find v final y. Okay? And this is going to come out, and v initial x is going to be 15, because sine of 30 is 1/2. Okay? So from this, we know 3 of them. And of course, with our rule of 3, if you know 3, you can find the 4th. Alright? So, we have change in y, v initial, acceleration, and we want to find v final, so we're going to use v final squared equals v initial squared plus 2a delta y. And we get 15 squared minus 19.6 times negative 18. Okay? And we get v final y is equal to negative 24. Now, when we take the square root of that, we should get, it could be negative or it could be positive. We want the negative because we know that it's going to be coming down when it hits, okay? Now, obviously mathematically we don't know that, but physics tells us, of course, and just logic tells us it's going to be coming down, so we want the negative. Okay? Now, to find v final, okay, we need to find both the angle, theta, and we need to find the magnitude. So v final is going to be the square root of v final x squared plus v final y squared. Simple Pythagorean. Okay? So when we Pythagorize, we've got 26 squared minus 24, well, plus negative 24 squared. And that should come out to be 35.4 meters per second. Our angles can be found using inverse tangent because we have our triangle here. Okay? This is 24. This is 26. We want the hypotenuse, or this angle here. Okay? Now, why do we want that angle? Sorry if I can erase that. We want that angle because that angle is the same as this angle. Okay, what we really want is we want the angle below the horizontal. That's not always what you want, but generally if you want it from the positive x angle. So, take tangent inverse of 24 over 26, and that's equal to 42.7 degrees. And there we have it. At impact, the baby cheetah will be landing at 35.4 meters per second at an angle of 42.7 degrees below the horizontal. And that is a general launch question.